Here we go. So how do I use properties of angles in circles? That's what we're looking at today. So there's three things. There's the major arc, the minor arc, and a semicircle. And then we'll hit those other two things later. So here is a circle. When you're looking at the major arc, your major arc is greater than 180, and it uses three letters. So like if you have, let's look at this right here. So this arc. So this is greater than 180. This arc is B, D, C. And that's for the angle BAC. There's lots of major arcs on here. Like you can do this one. I'm going to change to a slightly different color of green. So if you went from here to here, you can do this and go around this way also. That's another major arc. So that one would be ECB. If you called that BCE, it's the same thing. This works just fine. And so this is angle EAB. So major arcs are the bigger ones. The minor ones, so that same, let's do these same two. So that, the one that goes with this light green one I just drew, this is the minor arc. A, E, C. Yeah. So this is for angle. The minor arc is EB. It just uses two letters, and that goes with angle EAB. So let's also look at, do I have a different red I can use? Yeah, okay, sure. So let's look at angle BAC. Wow. BAC. So angle BAC is this one here, and this is the minor arc going from here to here. That's your minor arc. So we just call it BC. So those are pretty straightforward, I think. Your semicircle is BAD. I mean, you could call it BD also, because there's really no, like, to get from B to D, it's going to be that. So, yeah. So on your assignment, it's going to have questions like this. So for BAC, the major arc was, BDC, and then the minor arc for angle BAC was BC. CB is also correct. CDB is also correct. So that's the arcs. The other thing you're looking at today is central and inscribed angles. So with the central angles and the arcs are equal. So here, this is 40, this is also 40 degrees. If that's 40, these are equal. This is also 40 degrees. That means this is also 40 degrees. Remember that a straight line means it's 180, which means this would be 40. Wow, that looks like a 6. That means this is also 140, which means this is 140, and this is 140. And these should add up to 360. Circle 360 degrees. That's important. Something to not forget about is vertical angles. So that's 100. This is also 100, which means this is 100, which means, man, I need to do my zeros better. which means this is 80, which means this is 80. So if you're just given one piece of this, you can figure out most of everything else. So that is central angles. When the angles are at the center, it's just the same. Fix that 80. Maybe I should do the other direction. It just feels funny. Okay, the last thing is inscribed angles. So inscribed angles is where the vertex is on the circumference. So those definitions are up here. Vertex on the circumference, the angle equals 2 times. Oh, hey, you know what? This is wrong. Angle equals, of course. Well, I guess it's better I catch this now than later. It's 2 times the arc equals the angle. I said the wrong thing, but I wrote the right thing. Yeah, so 2 times the angle equals the arc. There we go. So this is 45. And then to find this other angle here, you do the other arc, 360 minus 90 is 270. Minus 130 is 140. So this other one here is 140. 140. Then over here, this is the angle. And this is the arc. So if this is 50 down here, that means this arc is 100. You'll also notice on this one, this yellow angle also goes with this angle. So this is also 50.